what's interesting is I always take a family history, and I always take a family history of Alzheimer's or cognitive dysfunction in brothers, in siblings, in parents. And if there's any evidence of that, we don't always check for the ApoE4 gene, but if there's that family history, and I want to segue to this as well, I'm always recommending at least 3 omega fatty acids, as well as them being ketosis. Now, the question there for you is, given your work on 3 omegas and your understanding on DHA specifically, if you're going to supplement your diet with DHA, how much and in what form and how frequently?
I've just had a number of conversations about this in the past week, and there's no simple answer, because the epidemiological studies would suggest that eating fish is beneficial for the aging brain, but the randomized control trials simply don't support it. Whether it's combined with or without EPA, 6-month studies, 6-week studies, Alzheimer's, MCI, it's very hard to replicate what we have learned from the epidemiology. So, the simple answer is any amount of fish or any amount of DHA is better than none, in my personal opinion. Start with what you're prepared to eat. If you refuse to eat fish, but you want to protect yourself with some DHA, then you're going to need the capsules. If you're a vegetarian, you can get algal sources of DHA. And I don't think you'd need more than 3. I don't think anyone's demonstrated that the benefits of omega-3 require a dose higher than 3 grams per day.
What about 1,000 grams, which is the common?
1,000 grams per day is going to be an achievable level that you should be able to live with. And eating fish would be better, I personally feel, because you're getting a whole cluster of what I've called, in relation to evolution, brain selective nutrients. And so it's not just, you're not hanging your hat on the hook of omega-3s, hoping that that's, again, the magic solution. There's always more to it than one nutrient, one fuel source, and
right,
so on.
That's something I've always said about the baby formulas. It's basically an ice cream or a baby milkshake that they've thrown some DHA in. And I'm not certain.
Well, at least the DHA is there, at least in some of them now, and it took so long. It was a huge battle to get even to that stage.
So what we're talking about is 2 separate things. We talk about ketones and energy provision to the brain, probably ketone glucose ratio. And then would you say that the DHA is separate and apart from that? Or are they all?
No.
So what is the correlation? What is the interlink between those 2?
So we got our neurons that are trying to talk to each other. You need a spark. You need to make a spark. That takes energy. But you need the receptors and the neurotransmitters there, and that takes DHA. So it's what I called in a review a couple of years ago. I was given an award by the French Society for Lipids, the Chevreul Medal. I call it the yin and the yang, the yin and the yang of brain health, basically. The energy can't do it alone. You can't get DHA from ketones. So you need to, one of the reasons the DHA studies have not been shown to be effective is possibly because they haven't addressed the energy deficit problem in the brain at the same time.
Interesting.
Now, the irony is, if we can go full circle, 30 years ago, when I was studying the metabolism of alpha-linolenic acid to look at DHA synthesis, guess where 90% of it went?
Ketones?
90% of the alpha-linolenic acid did not go into DHA, which is what we were focused on. It was degraded, beta-oxidized, and made ketones, saturated fatty acids, cholesterol. There was 50 times more carbon from alpha-linolenic acid in cholesterol, in brain cholesterol, than in brain DHA. And I was struck by this, and I thought, how does that happen? I learned about ketones from that.
Interesting. So could the DHA deficit from substrate, from alpha-linolenic acid substrate, be because the ALA is being diverted to energy production and production of other molecules, so it's not necessarily available?
Absolutely. It's being degraded, is being metabolized to other substances very quickly.
So let me ask you this question then.
It's the most beta-oxidizable of our common long-chain fatty acids in our diet.
Wow.
It's the most easily degraded to CO2 to use as a fuel. alpha-linolenic
And
acid.
does it cross the blood-brain barrier better than DHA or faster in a higher concentration than DHA?
I'm not a specialist on that, and I don't think there's any simple answer to it either, because there are different mechanisms. There's fatty acid transporters, there's LDL, there's a bunch of different mechanisms, and it's not my specialty.
Right now, I've read a couple of papers about delivery, and as you said, it's kind of confusing about what can cross and what can't cross.
Well, it's a question of redundancy again. If I was an evolving brain, I'd want to make sure that I could get my DHA from more than one source before I start committing to expansion and this whole evolutionary process.
So along that line, and I know again this is not your specialty, but it's right in the realm, cholesterol. We know that the concentration of cholesterol in the brain is one of the highest concentrations in the cells of the human body. I think I read that the brain is 1/8 of the body, but 20% of all the cholesterol is in the brain. Whatever the ratio was, but the concentration of cholesterol is very high. What does this common sentiment of cholesterol reduction, particularly in the older population with statins and with HMG-CoA reductase blockade, what does that do? You mentioned all of these important aspects of synapse function. It's not just one thing. What does a relative deficiency of cholesterol supply to the brain do? Brain does make cholesterol itself, as far as I'm aware. So
it has to.
It has to. So what do you see cholesterol provision to the brain as a concern? I know that David Diamond has a beautiful study that he quotes a lot where patients on statins and had cognitive impairment, they were taken off the statins, there was an improvement in cognitive function, and then they were put back on the statins and the same cognitive impairment occurred again. So it was defined that the statin was the problem. What are your thoughts on cholesterol importance in the brain and the function of decreasing overall cholesterol with statins?
Well, it's pretty hard to know exactly what cholesterol is doing in the brain beyond the embryo stage. In the embryo, if you block cholesterol synthesis, you get massive malformations of the head. It's Smith-Lemli-Opitz syndrome. Okay. So it occurs in humans rarely, but it does occur, and it can be mimicked by statins or other types. In fact, there's been a number of drugs that were abandoned because they were given during pregnancy for some reason, and it was determined that the malformations were due to the inhibition of cholesterol synthesis. So cholesterol, for gene expression in the brain, cholesterol is essential during embryonic development. That's a long way from aging and statin use to control LDL in older people, but maybe there's some parallels. So I'm not an expert on cholesterol, and I've been quite in tune with what David Diamond has been saying, and I feel very comfortable with finding different solutions to cholesterol than using statins. Statins also, some statins will induce seizures in at least in animals, and I don't know the extent to which this is an issue and whether it's contributing to seizures associated with Alzheimer's disease in older people. It's speculative, but it's not unreasonable that you would anticipate that. So I think that there are other solutions to our cardiovascular health. I think David has always been concerned about LDLs being exaggerated in importance. It's kind of like finding the guy to blame.
Right.
It's the opposite of the magic bullet, as it were. And as long as we can identify one person to blame, then let's put all our energy into that. And I think that's, again, misplaced, like putting too much emphasis on one single solution to these problems. Even if statins were beneficial for LDL and didn't cause cognitive issues, it still leaves the impression that I've solved my health issues if I simply take a statin, which is completely corrupting what actually common sense.
Well, let me ask you this question, and you may not know the answer to this. Again, this is just thinking. Two questions along this line. How does DHA get to the brain? What's the transport vehicle? Is it LDL? And typically LDL transports phospholipids or 2 fatty acid chains and triglycerides, which are 3. Do you know whether DHA or the polyunsaturated fatty acids, the 3 and the 6s, are delivered to the brain as triacylglycerol, as triglycerides, or as phospholipids? And because that has implications as well. And speculatively, is the delivery molecule an LDL molecule? Because I assume that the DHA is stored in the fat cells. When you say it's stored, 500 milligrams is stored in the body.
At birth, DHA is stored in
adipocyte, right? So that's our stories in adipocytes.
It's also present in the liver and can be contributing to brain DHA.
Right.
The short answer is I don't know. It's partly because LDL is one of the ways of getting DHA into the brain, like other fatty acids. Whether it's the phospholipid that brings it to the doorstep, crossing the threshold into the cell is a free fatty acid as far as we know. At what point does they call it flip-flop, and that free fatty acid can go back and forth. So until it's grabbed by some transporter molecule or carrier molecule inside the brain, it could just as easily flip back out as it flipped in. And just you can tell by my explanation that this is not an area that I have researched in any detail, and I wouldn't pretend to know, except to say that there are, again, redundancy is really important with these different fatty acid transporters. LDL plays it. You can knock out LDL receptors in the brain, and it doesn't change DHA levels one iota.
Interesting. So, yeah.
So this is one of the lines of evidence suggesting that redundancy is there, and it's there for a reason.
Right. But again, the use of statins, the LDL as a delivery molecule as opposed to something that causes harm, all of these things are fascinating questions. And I knew you wouldn't have the specific knowledge, but those are all reasonable questions to ask. Let me segue a little bit here to another thing that you write about quite a bit. And I'm confused about this a little bit. What is the importance of iron, iodine, selenium, copper, and zinc in the brain? Because you've written about that. And these are all things that people are obsessed about taking in our population. They take them as supplements. A lot of it has to do with COVID and that kind of thing. But you've written about specifically iron and iodine as being important in the brain. I know iodine for the thyroid, but what is the role of those things as molecules, trace elements in the brain?
If you go to the WHO website, and I haven't actually done this, but I'm pretty sure any search will show you pretty quickly that 20% of the world's population is iodine deficient, demonstrably, clinically iodine deficient. They don't have a goiter, but they have an impact on the physical development and the cognitive development of the child, and of course the adult as well. 20%, and that's 100 years after iodized salt was developed.
You know, the 82% of the patients I see for the first time are on thyroid replacement. And most of them have no idea why. They don't have a diagnosis. They've got an observation. You're hypothyroid. Here, for the rest of your life, you're going to be taking this Synthroid or whatever it may be. It's quite bizarre. And as we work with them, we can normalize those and get them off medication. But how does that
if you're a fish eater,
yes,
or shellfish eater, so you look at the natural populations, the populations eating the local food, the ones in the mountains are the ones that become iodine deficient, or in the, where was iodine deficiency first corrected by iodine itself, exogenous iodine? In the Midwest, in Ohio somewhere. I'm not sure, it doesn't matter which city it was, but it's Midwestern states. Why? Because nobody ate fish.
Right, the Minnesota area is very deficient. Also, it's very iodine deficient as an area. So,
the meat would be.
I just want to get to the shoreline stuff, because the iodine, the iron, the selenium. I mean, those are just so important. And
iron is neck and neck with iodine in terms of deficiency worldwide, and there are some solutions with some sorts of what they call sparkles or sprinkles. But it's not corrected the deficiency, and people are retreating from animal sources of food. They're retreating from salt and the natural sources. Iodine deficiency is occurring in westernized countries, in Europe and in North America, in pregnant women again. So it hasn't gone. And if you're not taking iodized salt and not eating fish, the chances of you being iodine deficient are quite good.
So what are your recommendations, both in terms of DHA, iodine, iron, for a large part of our population when they correct their insulin resistance? They go ultra low carbohydrate, they go on a ketogenic diet, but it's mostly terrestrial animals that they're eating. Very heavy on beef. You've got your BE, which is your beef, bacon, butter, and eggs. And that's a new popular trend, which serves people well in correcting the disease of insulin resistance. But in terms of DHA, iron, folate, what are your concerns, or do you have any, with people that are eating a high terrestrial meat diet, mostly carnivore diet?
Well, they're still going to be DHA deficient. Most of them. It depends if, unless they're eating very high quality beef, which may in some cases may be. But my approach is simple. Any amount of shellfish or fish is better than none at all. And so maybe that's very hard. Maybe that's not gonna happen in your BBBE people because they've got their way of doing it, and it's still. They will be getting they'll be getting more iodine, iron, and zinc and copper. Copper is essential for myelination. Menkes disease, swayback. Swayback is a disease in sheep. And so these metals were shown to be important in agriculture before they were realized to be important in humans. But Menkes disease is a copper deficiency, and it's a condition of hypomyelination because you can't make enough oleic acid to contribute to the insulating fatty acids in the myelin, because the conversion of the saturated fat to the oleic acid is copper dependent. So you can get them from meat and from eggs. Eggs are a great source of these nutrients as well. And so most of your BBE crowd are probably doing a pretty good job of protecting themselves nutritionally.
Well, that's why the egg is there. The egg has got everything in it. But really what you're saying is that cows aren't very smart because they got low DHA in their brains.
Well,
I'm being a little bit facetious,
but they're eating grass as well. So, right.
Yeah. But however, now this leads, so if you are going to design the ideal diet for you, and I think I just want to get into, we haven't talked about it because we've been talking about so many other important things, but give us your theory of shoreline development. Why do you believe that humans are human in terms of brain evolution, brain function? What component does the shoreline, is it a chicken and an egg? How does that all happen in human evolution?
The shorelines have access to the shellfish, the clams, the mussels, the frogs, the fish that don't swim very fast, because going back in evolution 2 million years ago, we didn't have the skills to hunt, and that includes fish. So we weren't out getting salmon, that's for sure. We weren't catching trout unless you were extremely lucky. And so but the slow-moving fish in East Africa, in the East African lakes, like tilapia and catfish in particular, had abundant sources of the brain's, the whole cluster of brain selective nutrients, including the DHA, the iodine, and the iron.
Why do they have that? Or is it kind of fortuitous?
It comes from what they eat, and it comes from the sea. The iodine is in the salt water.
And what's the value to a fish? Fish aren't very smart. What's the value to the fish of having DHA and iodine?
Well, it's able to resist. They've been around for 400 million years, so they've done something right. We haven't come to even to 1% of that. You can calculate it, but in fact, we're much smarter. But we risk burning out far sooner than many other species.
But what you're really saying is that we found shorelines fortuitously as pre-hominids. As
hominids, we found shorelines, and so not only
source of food.
And the food supply was important to get those nutrients. But remember, the infant is born with a fair amount of fat, and it's in adults, the brain is using 20% of the body's energy supply, but at birth, it's 75%. So when you think about brain evolution, it's all very well to think about the tools that we learned how to make, the stone tools to go hunting as an adult, mostly males. It's a very macho kind of concept. The question is, how did the infant brain, how did evolution allow us to dedicate 75% of the incoming energy to the infant to be used for an organ that doesn't even help it survive for the first 5 years of life?
Right.
And so there must have been sufficient energy to permit that process to put fat on. In the last 2 weeks of pregnancy, 90% of the mother's transfer of nutrients to the infant, to the fetus, goes to the fat. It's to put down the fat. How did she have that excess available energy to do that? and allow a big part of that to fuel the infant brain if they didn't have a stable food supply, a reliable source of the nutrients needed, of the energy, a certain sedentary lifestyle. Fetal obesity is essential for normal development. We're terrified of the word obesity, but if you're not born with a certain amount of fat, if you're born premature or low birth weight, your risk of neurodevelopmental delay goes up exponentially. And so it's all part of the solution to the protecting the brain is the energy supply, and a long-term beyond weaning, because all mammalian milk has MCT in it. The first MCT were identified in goat's milk. Goats aren't known to be particularly smart, but they have got lots of C8 and C10, capric and caproic acid, and caprylic acid. And so there's something different about a goat and a human. It's not the amount of MCT in the mother's milk. It's the length of gestation, and it's the amount of fats that's born. We're the only species born with fat babies.
And that's often the brown fat, which has a much higher concentration of nutrients. It's not just an energy store. There are a variety.
Well, the brown fat has a lot of mitochondria, which help generate heat.
Yes.
I don't know whether mitochondria, brown fat is part of our evolutionary story in relation to the brain, but potentially.
So the other question, it was a question I was trying to come up with a little bit ago. You talk about MCT and you talk about ketones. Ketones are either a direct source of energy or a precursor building block for longer chains of fat. MCT oils are your short chain, your C6s, C12s, the medium chain. Are the MCTs broken down to fuel, or are they used? We talked earlier on about the myelin sheath, and you talked about the C18, C20, the longer fat saturated and polyunsaturated and unsaturated fat molecules. Is MCT oil in your thought process primarily used toward the fuel, the mitochondrial utilization broken down and used by mitochondria, or is the value in the shorter chain carbon molecules as integral to membranes? I don't know if you know that, but there seems to be a difference between MCT and ketones.
There's essentially no medium chain fatty acids in membranes, definitely not in the brain, and probably not in any other organs except the adipose tissue while you're pre-weaning. MCT are a generic term, as you know, and they start presumably with the 6. I don't know whether the 6 is keto. Actually, we now know very recently that the C6 is ketogenic, but it's a very recent discovery. C8, so if we ignore C6 for the moment, C8 is the most ketogenic MCT. Go to C10, it goes down gram for gram. We've studied it. C12 is essentially not ketogenic. C14 either. So in coconut oil, where you've got MCT that favor the 8, the 12, and the 14, you have a very poor ketogenic effect, which doesn't mean coconut oil couldn't be beneficial, but it's not because it's not ketogenic enough to be beneficial as such, whether those ketones would be for building myelin or for fueling the brain. So there's no storage. MCTs are not contributing to the membrane structure anywhere in the body. They're still degraded. So if we give 30 grams, as we did in our study, I would think that probably, don't have the hard number, but I would say greater than 75% is completely oxidized to CO2, possibly via ketones, but not necessarily. The direct oxidation, they don't need carnitine to get into the mitochondria, so C8 will be burned to CO2, and unless you stack up enough acetyl-CoA, you won't make a ketone molecule from it.
Right.
So ketones are not the only endpoint derived from MCT.
So you're talking about the MCT, so you're talking about the fuel pathway along that line, and they're all going toward fuel. They may be going towards making brain lipids as well. Right.
C8 can definitely get into the brain, and it could be anabolically useful. You can also couple it to certain proteins and certain hormones like ghrelin. I have no idea whether the biological importance of that.
And you talk a lot, you've written about coconut oil and the importance. That's primarily not because it's monounsaturated, but because of its MCT content. Is that correct?
Well, I've only made the point that it's not ketogenic. And so that doesn't mean it's not beneficial for the aging brain. And if anybody's taking coconut oil to try and stave off Alzheimer's disease, I wouldn't change that. But I wouldn't also be under the misunderstanding that it's because of making ketones. But the C12 and C14 could have antimicrobial effects, they could be beneficial as antivirals. So that's a potential effect. It could be an effect on the microbiome that we haven't really explored that could be beneficial as well. So it's not just ketones. At least with coconut oil, it's not just ketones.
So to kind of go to the final set of questions, based upon your research, based upon your knowledge, I'm going to ask you two separate questions. If you were sitting on the US Dietary Guidelines Committee, which is our, you know what the US Dietary Guideline Committee is, you have something similar in Canada, what recommendations would you make for population dietary recommendations as a whole? Where would you put emphasis? Where would you alter some of their recommendations? What therapeutic strategies would you use to counteract this awful disease of neurodegenerative, or awful cluster of neurodegenerative diseases? And how would you improve the quality of function of this massive aging population? Because our aging people, the volume is high, but the liability is great because so many of them have cognitive impairment or neurodegenerative disorders. So they become a liability to our society rather than a contributor to our society, like the elders of so many hunter-gatherer tribes used to be. What recommendations would you make?
Rob, I'm not going to take the bait as far as if I was on the dietary committee. It's a bit treacherous, but for another reason. I don't think this is just a dietary problem. It's more. It's about exercise. It's about social involvement. It's getting a family support, and so the bottom line, and this is not a facetious comment, forget Alzheimer's disease. If you're young enough to forget if you're young enough to not have it, if you're in your 20s, 30s, 40s, let's say, then think about being healthy. Think about being socially engaged. Think about your sleep. Think about fatigue. Think about stress. Think about meditation. Think about Tai Chi. Think about doing some exercise. Think about some sort of sport that you could take up that would be fun. It's not a competition. It's about having fun with your friends and maybe having a beer afterwards or some social activity afterwards. Think about your health in a global sense. It's not just about your diet. You can have the best diet to whatever the recommendation is. That's not a guarantee that you're going to be healthy. It's not a guarantee that you're not going to be stressed. If you're working 18 hours a day and under whatever conditions they may be, is that really the solution? Is diet really the solution? It's part of the solution, but it's just part of it.
Well, okay, so let me bring this a little bit more home for you. And you'll understand, I'm not trying to trap you or do anything like that. I'm going to personalize this, okay? I'm in my late 50s. My brain works fairly well, but I have a mother who's dying of Alzheimer's. I have a grandmother who died of Alzheimer's, and I have an ApoE4 allele, one copy. I am doing most of what you're doing, except perhaps for the sleep. I've got a little baby at home. I'm very engaged and involved in all the, what I call self-care activities. What nutritional advice would you give to me to support my healthy cognitive aging and to reduce my risk of dementia, given that probably genetic likelihood?
Well, I would limit your sweet foods to things that if you insist on eating sweet foods, then be smart about it. Eat the best quality chocolate that you can afford so that you don't need to have the whole bar before you get the buzz. Good chocolate is like that. If you love ice cream, don't eat it so often, but eat the best quality that you can afford. By all means, pay yourself a little treat if you want to, because I don't think several hundred grams of glucose or sucrose per week is going to be life or death. But be smart about it. Get out and do some exercise. Try and reduce the stress, the anxiety, and try and get some good sleep, because that's probably one of the things we underrate the most, and it's probably one of the most important. And get some exercise in a socially agreeable setting.
And would you suggest it's a good idea, or would you recommend, and I know you're not a physician, you're a PhD, but would you, based on your research, purely based on your research, see taking a fish oil or a krill oil or cod liver oil in an advantageous way? And would you suggest taking exogenous MCT oil? I am myself pretty close to carnivore. I'm about 95% carnivore, and I am in ketosis. So I measure my ketones, I'm insulin sensitive, I'm fat adapted, but given my background, and I'm talking about myself, but there's a large cohort of my patients that have a similar family history or a similar orientation, and probably do have a degree of MCI already. Would you recommend those exogenous supplements, or do you think that a ketogenic lifestyle is adequate for someone at high risk?
It's speculating.
That's what I'm asking you to do, yes.
I think you're probably in a degree of ketosis that's adequate. An MCT is only maybe going to add 10%, or maybe not even 10% to your daily. Don't forget, it's only related to the dose you take. So if you take it once a day, you're gonna get some sort of mini peak on top of your basally increased ketone production. It's going to last maybe 2 hours at the most. DHA, you might be low on DHA, but I would think that the whole purpose of this discussion that we've had is in terms of protecting the brain as we get older, is giving yourself a chance to have normal insulin sensitivity and normal insulin signaling in the brain. If you know that your insulin sensitivity is pretty good and your glucose tolerance is good, you're probably in as good a state as you can get metabolically. MCT can improve glucose tolerance a little bit in pre-diabetic women eating an average diet, and they're not eating carnivore like you are. So I think I would speculate, I would predict that you're in a pretty good state metabolically, with the possible exception of DHA, which could potentially be advantageous to have a source of DHA. If you don't eat fish, then you.
Well, I forgot that question. I should have added that in. Would you recommend a shift more toward marine food, fish and shellfish, or is that not adequate? Would you still take DHA in addition?
I would recommend eating fish once a week and perhaps twice a week if you like it, or shellfish, because crab and scallops and these other sources of shellfish are just as good for this purpose as fish is. So I don't think you need overkill. I think you need to get to a certain threshold, and beyond that, maybe a DHA supplement would be beneficial, but the clinical evidence is simply not there in terms of cognition.
And I'm just still baffled, or not baffled, but astounded by that 23-year-old person who has MCI. That is just...
It's not a person. It's 10 of them. So I'll send you.
But what I'm saying is that cohort at that early age, because PCOS is a common disease we treat here. I work with a fertility clinic, and they send me, it's one of the commonest causes of infertility. So they send me all these young moms or women in their 30s and 40s who got PCOS, desperately want to get pregnant. And we use a ketogenic diet to get them there, to try to get them into ketosis. But you've given me a lot of food for thought in that regard as well, in addition to the importance of this in the pre-pregnancy and intrapartum, and if you're going to breastfeed, postpartum time frame. It's just because what we've talked about previously is staving off disease as you get older, but this is also optimizing, giving your child the best shot at the healthiest brain it can have, given its genetics.
Well, one of the most important risk factors for Alzheimer's disease is low education in the early years, primary school and middle school. So if you've an autistic child or a child with developmental behavioral issues, chances are they're not getting a very good education at that age. I'm extrapolating, it's not my field, but I think it's one of those things that would contribute to an enhanced risk of Alzheimer's disease later in life, just as metabolic dysregulation does in a 20-year-old.
Right. And for my mom, who's 88 years old, she's got dementia, she's got Alzheimer's, she's physically very functional, but the typical short-term memory, she's that middle ground, not wheelchair-ridden kind of cognitive failure, but can't remember a thing. Fortunately, she gets to meet her grandson every time we call her again. Oh, who's that? So, that kind of functional but no brain. Would you suggest there's any benefit to DHA or 3-omegas in that population, the diagnosed Alzheimer's population?
Well, I guess you've got to be practical, and when in one sense you've nothing to lose. It's not dangerous. The side effects are manageable or non-existent to manageable. So why not? Not to expect anything, but there may be some pleasant surprises. It may not be too late. I don't know if there's a point at which it is too late. So if she's in a setting where this can be managed by a caregiver, and she's willing, of course, to do it, then there may be some surprises that even she will notice, or that others will notice and realize, hey, we've just got a little improvement here, which
well, I can tell you
because there are good days and bad days.
Absolutely, there are good days and bad days, and it's very
and so what you're trying to do is increase the ratio of good days to bad days, and maybe that's achievable. I've had some remarkable anecdotes sent to me by various people where personal experiences, case histories, if you will, and it's some people have had unexpected success stories. So I wouldn't give up on her just yet, especially if she's physically able to exercise.
Well, that's exactly what I was going to tell you. Since my father passed away, we have her in a regular daily exercise routine, and I've just connected the dots with you telling me that. Now, this is anecdote, but with you telling me that I believe is a component of both her mood as well as her cognitive function, and the two are somewhat related. Plus, she's eating a little bit more ketogenically, but very, very interested in that side of things. Plus, I've got her in some fish oil. But
we're starting a study where we're reducing carbohydrate intake in a residence near us here. There's a lot of logistical planning to do, but we're just trying to reduce it by 50%.
Interesting.
To get some of them off insulin. Most people would say, well, 50%, there's no big deal there, but logistically, it's an adaptation thing to demonstrate that it's feasible and acceptable. And then
I'll tell you, there's a Swedish study that looked at carbohydrate consumption in diabetics, and a 10% reduction in carbohydrate consumption has a 50% improvement in A1C. So we even a small change in carbohydrate consumption makes that difference. But there's carbohydrate reduction, and then also the addition of fat, ketones, and then I think the moves that I'm going to make is probably not do the MCT, but make fish and shellfish a more regular component of my diet. Stephen, there's one other question, and I know this wasn't on the list of questions I asked you, but as I was looking at your work, I noticed, and you can tell me if you don't want to answer this question, but in our group of folks, and certainly something that we see a lot of, when somebody publishes a paper that we radically disagree with, or where our belief system is opposite to their belief system, it's not uncommon for us to look at, let's say, someone who's publishing a pro-vegan paper, and I'm going to use myself, not include you in that. It's not uncommon for us to look at who supports their research and connect their production of that work to their bias about who funds their research.
It's conflict of interest, for sure.
It's conflict of interest. Now, having looked at your disclosure of conflict of interest, I saw that Nestle is somebody who sponsored you, who has provided funds to you. How do you so if I was on the other side, if I was wearing the green hat, and how would you answer that question? Can we believe your research because of your bias related to your sponsors?
That's up to you. Each person has to look at the sum total of the results. If we were the only people producing the results that we have reported, then you might sort of wonder how's that possible? No one else has seen that, but we're one of many. Practically monthly, there are new studies that are coming out. It's been confirmed that the brain, Alzheimer's disease can take up, the brain can take up, in Alzheimer's disease, the brain can take up ketones perfectly normally. That's been confirmed elsewhere. It's been shown that the ketogenic metabolizing enzymes, the gene expression of them is normal in Alzheimer's disease. So a very different approach to showing that's normal. Ketogenic diet for Alzheimer's disease has demonstrated cognitive benefits. So I feel comfortable in the sense that other scientists, whether Nestle was supporting our work or not, other scientists have demonstrated the same things, and that
The
validation
reproducibility is the factor there.
That's the key, and so I feel comfortable about that. Now, Nestle has a bad reputation, and perhaps for good reasons in some respects, both environmentally and in the way they've distributed the various products for pediatric nutrition worldwide and so on. If you want to listen to me, then the reason I feel good about it, of what they're doing, is that no one else in this ketone space, to my knowledge so far, has bothered to produce a placebo, whether it's an MCT or an ester or a ketone salt. I'm aware of nobody. And I had a trial funded by the Alzheimer's Association to do such a study with a different sponsor, with a different product. And they backed out once the funding was guaranteed, and they backed out. So if Nestle had a bad reputation in some areas, I think their commitment to this area, I think, is genuine. They've committed money to it. They provide us with excellent products, and they've given us the opportunity to explore some ideas and push this forward that I don't think we would have had otherwise.
And do you have autonomy of your results? Do you have?
They belong to the university.
That at all?
The university owns our results, and the university has chosen to negotiate a contract in one case with Nestle to transfer the technology and to the product that became one that's on the market now, called Brain Expert.
Excellent.
But those results belong to the university.
And just I hope you've got a few seconds to answer one more science question for me. And this is it's my mistake, because I have a significant cohort here in Florida. We have a lot of soldiers in Florida. Especially in northern Florida, we've got a big Marine base, a big Navy base. We've got Air Force. We've got and obviously the war's been going on for 20 years in Afghanistan, Iraq. We have a number of soldiers that I have as patients, young men typically, one woman, who all have CBI, cerebral brain injuries or chronic brain injuries from trauma. And these are guys that were blown up, that were shot, that had significant injuries. Do you know what? And a lot of them have gone through the whole recovery period. They're doing fine, but they're still plagued by the consequences of some brain tissue loss. Do you have any guidance on a ketogenic diet, MCT oil, or brain protection when you forget about Alzheimer's, forget about neurodegenerative stuff, but really brain healing and brain repair and scar management in people who've had a CBI?
The short answer is no. I'm aware of a couple of rat studies that were done by Prinz was her name. It was a woman in California, UCLA, I think, who had done some animal studies to try and mimic the human situation. But I would point you to other people to look at this. But I think, if there were publications out there, I think we'd know about it. So the bottom line is, I think that there may be some work going on. Actually, people like Jeff Volek, I think, are very interested in this issue. Ken Ford at the Institute of Human and Machine Cognition in Pensacola as a very serious interest in this field as well. And there are probably quite a few others that I can't think of at the moment. But I think there's every reason to believe that it would be a beneficial effect to have ketones to help with repair processes, reduce inflammatory processes. But I'm not aware of convincing evidence that it works.
Right. And, I've got anecdotal evidence, but it's biased anecdotal stuff, because these are folks that have come to us, they've already been on this, or we've tried it and we've seen benefits, but I've got to declare my bias in that regard.
But there's a logistical or a type of issue. It's like with epilepsy. I mean, it took a long time to demonstrate, to satisfy people that the ketogenic diet was beneficial in epilepsy, in part because we had no controlled trials. And every child's epilepsy is a little different, even if it's a grand mal or an absence or whatever it is, myoclonic. And TBI is much the same. How do you do a control study in TBI when everybody's injury is slightly different, both physically and probably psychologically as well? So that you've got two levels of injury overlapping in many cases, I'm sure.
Right, and that is the challenge. It's a very diverse group of injuries, and some of it's blast, some of it is penetrating, so and some of it's accidental traumatic, motor vehicle accidents, that kind of thing. So we do see the full spectrum. My anecdotal evidence is that it works, but I'm heavily biased, and certainly we see no downside to it.
But you might go to the Metabolic Health Summit in a month's time, or 5-6 weeks time, and perhaps there's some people that are there that can help fill you in. I don't have any firsthand experience, though.
Yeah, it's a strategy that we're using because these patients self-present, but it's nice to
you have
have
nothing to lose,
exactly,
and possibly something to gain.
Yeah. Well, wow, this has been so insightful. I thank you so much for sharing this knowledge, and I hope that we didn't infringe too much on asking you to extrapolate some information, but this is absolutely wonderful. And I'm going to try to summarize over the next little while, listen to this a few times and summarize some of the salient points, because there is so much clinical applicability. And I think from two perspectives, as you've said, it probably will do good, but it's certainly not going to do harm. Is that a reasonable?
It won't necessarily. You mean in TBI?
No. Forget about TBI. Generally, in neurocognitive stabilization, maintenance, or possibly an improvement, I don't see anything that we've talked about so far, even if we're completely wrong, as being deleterious.
I don't think there's a downside. I just wouldn't want people to assume that this is as a solution in itself. It's part of the solution, but it's not a standalone solution.
No, and that's the whole point. It's worth trying. We don't know. I'll let you know in 20 years' time whether or not, if you get a coherent email from me, it's probably working.
Right.
but
or from your son.
From my son, exactly. And we've put our money where our mouth is, literally, with him, because he's being raised in a ketogenic way, and we'll see how that works. But even with him, he loves his oysters, he loves his sardines. For an 18-month-old, that's not bad.
Absolutely.
But it's also helped us to understand some of what you're talking about. So I'm going to try to put this together in a clinically applicable way. Even some of those trace elements are can be important, especially if they're running a little bit low. The iodine, the iron, the selenium, the copper, the zinc.
Iodine and iron are at the top of the list. Any search will tell you that there's a huge part of the population worldwide that is still deficient. How did we evolve under those circumstances if we were deficient for the past 2 million years? It's impossible.
Right.
So some of us weren't, and the way we solved it was.
I think the shoreline story is so important, not just from a brain development perspective, but from a survival perspective. We had access to animals coming to feed at the water. We had access to water, and we had access to water to grow crops, potentially. So there was all kinds of benefit there. Golly, I'm flooding with questions. Biome, any concerns about the biome?
The microbiome, you mean?
Yeah. A lot has been made of that.
No, I'm not going to go there. I would just be babbling and
I try not to go there as well, because it's a little bit anti-human for me, in that the human intestine is more enzymatic than it is bacterial based, but that's all I'm going to say about it. That's part of our evolution.
I don't have anything that I
could defend. Pop up all the time. But I think I really want to thank you so much for spending this time. We've gone way over time. I really appreciate this.